you still have that paper that I sent you from Tuesday?
Should be able to retrieve it. That was the 9th.
Yeah.
There it is.
Yeah, I just wanted to work on the backside, and because I have a test tomorrow on like Conics, so I just wanted to, and I really need to get a good grade on
Okay,
it.
so we just need the second one. Did we finish the first side?
Yeah, but yeah, I just need to get those all really good.
Okay. We didn't do 7 yet, did we? We
No.
talked about doing it, and then.
Yeah, I think so. I think we ran out of time.
Yeah. All right, as I mentioned before, let's see. The way to do all of these conics, when they give you the polynomial in standard format, which is what this is, standard format's pretty much where everything's on one side and zero's on the other. So
Okay.
the process is to complete the square.
Okay, so how do you complete the square when there's not a second x?
Okay, that just means that it stays x squared. In other words, h is 0. So that's a horizontal ellipse. If it's a vertical ellipse, then switch the A and the B. In other words, the A always goes with the major vertice. If I have an ellipse that's out there like that, the center of it is H comma K. I like to call it the major radius and the minor radius, even though they're not radiuses, but it's like a circle and they're close to radiuses. And if it's a vertical ellipse, then the major axis is there, so A has to always go with the major axis. That's for sure.
Okay.
Okay? So we have to know that. We won't really know whether this is a vertical or a horizontal ellipse until we put it into this format, or something that looks close to this format. Alright, so let's start by grouping the x's together and the y's together. And put the number on the other side. Okay, since there's no x term, then it's going to be x squared. H is 0. But here, we can complete the square. What do we have to do before we can complete the square? You have to make sure that the coefficient of the squared term is 1. So we have to factor out that 36. The trick in all of these is to make sure that every step you do not change anything. You merely rearrange it. In other words, my second line there is the same as this polynomial up here. I haven't changed anything. I've just rearranged it. Now, how do we complete the square now?
So then it would be y, or pull out a y, right?
No. The way you complete the square is you take half of the coefficient of y, which is 4, so half of 4 is 2, and you square that, and you add it right there. And the purpose of completing the square is I'm going to be able to write this thing now as y plus 2 quantity squared. And that's what I'm looking to do, is write it as a linear term squared. Notice the general format is y minus k squared or x minus h squared. So that's why we have to complete the square, is to get it into that format. However, let's back up before we get there. When I wrote 4 in, how much did I add to the left side of the equation?
4. 36 times 4.
Right.
So
144. So I have to add 144 to the right side of the equation. Now I have not changed anything. With me?
yes.
Okay. Now let's rewrite it. Now we have x squared plus 36. This, once again, I'm going to write as y plus 2 squared equals 36. Now, the key with ellipses and hyperbolas is that they're equal to 1. You've got to try to get, notice the general format is equal to 1. So once you get to this stage, the purpose is to get it into the general format. How can I make that 36 be a 1?
Divide it by 36.
And which means I got to divide everything by 36. Okay, now the left side becomes x squared over 6 squared, because I want to know what a is, plus y plus 2 squared over 1 squared equals 1. So now I know that because 6 is bigger than 1, a is 6. And we are looking at a horizontal ellipse. I can't graph it on your paper, but I can graph it here. Where is my center?
0 and 2.
Plus 2 or minus 2?
Plus 2. Minus.
Minus 2. Look at the general format. It's always x minus h or y minus k. It's never plus. Not until you get to calculus. Then you deal with x plus h's. But at all math, it doesn't matter whether you're doing translations, vertex format, conic sections. It's always x minus some number and y minus some number. So if we're looking at a y plus 2, then k has to be a negative 2. You see that? In other words, if we were looking at y minus 2, then we would be at plus 2. But it's the opposite of the sign you're looking at here. So right there is my center. 0 minus 2. And I can draw let's draw our ellipse like this. And this distance is 6. This distance is 1. A and B. What is my vertex right there equal to?
6 and, or -2 and 6, or 6 and -2?
Correct. And over here?
-6 and -2.
And right here, and right here. Top one?
-1 and 0?
0,
Or
-1. And then this one is 0,
-3.
-3. And there's a relationship with A, C, and B. C being the distance to the foci. There's a foci there and there's a foci there. This distance right here is C. How does C relate to A and B?
C squared equals A squared minus B squared.
This right here tells you that A always has to be bigger than B, because when we solve for C, it's going to be the square root of A squared minus B squared. And if you got the wrong number for A, in other words, if you got them backwards, you'll end up with a negative number inside there. So if ever you end up with square root of a negative number, you know you just have your A and your B backwards. So what is C in this?
So that would be 36 minus 1. So 35. So square root of 35.
Yeah. So let's see. Identify the vertices and foci. We've done the vertices. So what's the coordinates on both foci? That one there. And
So
here.
it's square root 35, -2, and then negative square root 35, -2.
Okay. And obviously if our center was not on the y-axis, we would have to add these to the center to get the vertices. All right. So based on let's draw this before we figure out what it is. That's helpful because it points out to you whether you're dealing with a horizontal or a vertical ellipse, for one thing. So if I go 3, 6, there's the center. And one vertex is at -5, 6. Over there. And the focus is at 3 plus root 15, 6. In other words, the focus is on this line. In fact, it's over here. And that's the way you write these things. You don't convert them to decimals. You combine a real number with an irrational number in that manner. Do I have a horizontal or a vertical ellipse?
Vertical.
No, the focus and the center mean that it's horizontal. In other words, the focus is always along the major transverse axis.
Oh,
I
right.
have an ellipse that looks like this. I didn't leave quite enough room, but this is supposed to be the center. This is the major vertice, and this is the focus. So let's come up with the equation. What's the general?
So it's y minus k.
Start with x, because that's just,
So x,
yeah,
x
x minus h. In other words, every time you see the standard in a book, it's going to start with x. I realize the associative property holds, and that we could switch them up if we wanted, but it's just easier to remember if you always start with x. Okay, so let's fill in everything we know.
So
We need h, k, a, and b.
h is 3. K is 6.
It's a. A is the distance from the center to the vertice. How far is that?
8. So 4 or 3.
64. 8 squared is 64. How do I get b?
Isn't it the distance between the center to the top of the ellipse?
It is. But they didn't give us that. What did they give us? They gave us the focus. What does that tell us? That tells us what c is. In other words, this distance right here, oops, that's c. So what is c here?
Square root 15.
Okay, and the formula is
A squared minus b squared equals c squared.
so we can solve for b. In other words, b squared, b is going to be the square root of a squared minus c squared. Well, we know a and c, so a squared is 64, c squared is 15, so b is the square root of 49 or 7. So b squared is 49. All equal to 1, there's your equation of that ellipse. And that's the way these problems always go, is they give you all the information you need to calculate h, k, a, and b, but it's usually not, they don't give it to you directly, they give it to you by way of telling you what c is. So this is a very typical problem. Now, eccentricity. Hold on a moment. Just want to make sure I get it correct. Our conics. Hold on. eccentricity is a measurement of how flat the thing is. Hold on, I'm still looking for its formula. I think it's C over A, is it not?
I think so.
Alright, we'll find out if that's not right. It's either C over A or minus C over A, but I'm pretty sure it's C over A. So, C over A equals root 133 over 13. So they just gave us two of the things we need. And again, let's figure out whether it's vertical or horizontal, because we need to know whether to put the A under the X or under the Y. The vertices, 14 minus 9 and minus 12 minus 9. So again, that is a horizontal ellipse, because if they only give you one vertice, it's the major vertice, not the minor one. Even though they don't say major, usually they'd say major. Because clearly we have a distance to the major vertice and we have a different distance to the minor vertice. So where's our center at?
In between 14 and negative 12.
Okay, that's at plus 1. If we add those two numbers together and divide by 2, we get it. Okay, so that is 1 comma minus 9. So let's see.
So like if both of them have the same y, you can just add the two x's together and divide by 2 to find out what it is?
Yeah, in other words, whichever number is the same, in this case the y is the same, that means horizontal ellipse. If the x's were the same, it would be a vertical ellipse. Notice that if I have a vertical ellipse, the coordinate of that vertice is the same as that on the x-coordinate. So that's why I like to draw a picture of it, as it tells you, first of all, immediately whether you're dealing with a horizontal or a vertical ellipse. It's horizontal, therefore my equation has to be x minus h squared over a squared plus y minus k squared over b squared equals 1. So let's fill it in. I'll start up here. Help me?
Okay, so each equals 1.
Okay, so x minus 1 squared.
And then k equals positive plus, so it's y plus k.
Y plus 9.
Yeah, that's what it is.
Yeah, I know. Okay. What is a squared?
13.
Looks like a is 13.
So 13 times 13 is...
I'm just trying to figure out if, in other words, eccentricity is a ratio. So just because it's root 133 over 13, I don't think that necessarily guarantees that C is root 133 and A is 13, although it appears to in this case. Let's see. We're gonna be able to calculate B based on those values for A and C. So we'll assume that A is 13. It must be.
So it's
13 squared is 169. And how do we get b?
So do b equals 169 minus.
It's the square root of a squared minus c squared. So it'd be 169 minus 133. Or the square root of 36, which is 6. There's the equation of your ellipse. Now, when I was wondering whether eccentricity was c over a or minus c over a, I guess that was silly. It can't be minus c over a. Notice what eccentricity means. If it's the relationship to the focus relative to the vertex. So if that number is 1, you have a circle. If it's a big long ellipse like this, where the distance to the vertice is, that's a, but the distance to the focus is less, then the flatter your ellipse, the closer that c gets to 0. So a low c is a very flat ellipse. A high c is a circle. In other words, if you get an ellipse that's just barely oval shaped like that, well, the distance, the focus is very far, very close to the vertice. So c over a is like 0.9. So if you get an eccentricity that's close to 1, it means that you're closer to a circle than you are a real long ellipse. And that's what eccentricity is about.
Okay.
All right. Let's talk hyperbolas. They're a little different. They're similar to ellipses, but they don't look anything similar to ellipses. But the equation is similar. And the equation, I'm going to leave out the h and k just for effect. We'll talk about an ellipse that's at the center, at the origin. I'll come back and put the h and k in when we need to. I'm just trying to explain the concept.
Okay.
With hyperbolas, a does not have to be bigger than b. And the relationship between a, b, and c is c squared equals a squared plus b squared. In other words, it's the same equation that you use for the Pythagorean theorem. So that's the way to memorize it, is hyperbolas are Pythagorean theorem. Ellipses, c squared is equal to a squared minus b squared.
Okay.
Let's draw a hyperbola to illustrate what a and b are. First of all, imagine an imaginary rectangle that isn't visible, but it's useful for our purposes to draw it. And the distance for a horizontal ellipse, that's A, that's B. And the ellipse is formed by taking the imaginary diagonal line of that rectangle and the hyperbola approaches those diagonals. They're asymptote. So the hyperbola conceptually is a lot more complex. but its center, the one I've drawn here, the center is at the origin. And that's why there's no h and k. And A is always along the major transverse axis, which in this case is the x-axis. But if I had a vertical ellipse, hyperbola, then if I draw a line between the two vertices, that's the vertical axis. So in this case, A would be this measurement, and B would be the other measurement of this box. You with me?
Yeah, so how do you know how to make, do you get points
We'll
box
get
on?
there. I'm getting to there.
Okay.
The difference between a vertical and a horizontal hyperbola is, with a hyperbola, the y squared would be first. In other words, if I had this hyperbola over here that I've drawn, I'm looking at y squared over a squared minus x squared over b squared. So kind of think of it as the a always goes with the variable, the first variable you write. If it's under the x variable, then the major transverse axis is the x-axis. If it's under the y variable, the major transverse axis is the y-axis. And the difference in the polynomial, in other words, when I look at this, I can see that that's y squared minus x squared. That immediately tells me that I'm looking at a vertical hyperbola. And that's all I need to see. I don't care at this point. I'm going to care, but I don't care where A and B are. I just can tell by looking at that thing that it ends up being y squared minus x squared, and that makes it the vertical hyperbola. If you change the signs and make this x squared positive and this y squared negative, then it would be a horizontal one. That's all you need to see to know which one you have. So let's go back and figure out what everything is here. And again, we've got to complete the square. Because there's an x term here, I know that the center is not at the origin. It's got to be not. If it was at the origin, there would be no x term, just like there's no y term. The center is on the y-axis, but it's not on the origin. So let's rewrite this thing the way we need it to be, which is this format here. So 9y squared minus, now here's where it gets a little tricky. What's this sign need to be on the 2x?
Positive?
Yeah. In other words, again, I can't change anything. So all I'm doing is rearranging this polynomial. What I've written now is exactly this. So now let's complete the square inside the parentheses. And when you complete the square, you're always putting a plus. It's never a minus, because we're always squaring something to write in there. So what do I have to write in there?
1.
Correct. So I got to add 1 to the other side. That's all I added to the left was a 1. Ooh, let's hold on a moment. What did I do to the left side of that equation when I wrote 1 in there?
It was a negative 1.
I subtracted 1. So I got to subtract 1 over there. This is very tricky with hyperbolas when it's vertical hyperbola. You got to be very careful with your signs. Okay, so now let's rewrite it. We have 9y squared minus, this becomes x plus 1 squared equals 9. Now do you remember what the next step is? It's the same next step with pretty much ellipses and hyperbolas.
Divide both sides by 9.
Okay. So that gives me y squared, and I'm going to go ahead and put 1 squared down there. And put 3 squared instead of 9. Now I know A, B, and the center. So let's list it. The center is where?
Negative 1, 0.
Uh-huh. And A is what?
1.
B is
9.
3.
3.
That's why I write it this way. In other words, it's always the square root of the denominator. I could have written 9 there, but then you'd have to take the square root of it. Okay, and what is C going to be? Because it says we need to write the foci in. So here's our standard equation. So what is C?
So 1 plus 9, so 10. C is the square root of 10.
Okay. And that's all we need is that information right there in order to graph it. Start our graph with this rectangular box. And when I say imaginary, your final graph, you don't have the box in there. You're not supposed to. I mean, you can, I guess. Nobody's going to object if you have a dotted, but make it a dotted line. Okay? Our major axis, how do I draw the box? What are the dimensions of my box here?
So would it be...
Whoops, hold on. Uh-oh.
So you're at negative 1
Hold on.
and 0, right?
One moment. I seem to have lost control of this thing with my cursor. This is not good. When my cursor starts jumping around like that, I usually have to reboot. And I may have to here. Let me see if I can regain control without rebooting. I don't think I'm going to be able to. Jade, I'm going to have to reboot, and we'll do a final 15 minutes as soon as I get back to you. It's liable to take me 3 or 4 minutes to reboot. I apologize, but I can't do anything here.
No, you're fine.
I'll talk to you in a few minutes.
All right.
All right, bye-bye.